going to be looking at number 34 now as we go through our chemistry review packet. Once again, you should have a periodic table with you, and you should have the packet itself and the polyatomics. There's a chart given for number 34, and it shows you mega, kilo, deci. It shows you different prefixes, commonly used prefixes. Number 34 is going to ask you this. Number 34 states, what is the metric system prefix for the quantity 0.000001? Well, if you were to transfer this into scientific notation, you would end up with 1 times 10 to the, it's going to be a negative because it's smaller than 1, 1, 2, 3, 4, 5, 6, times 10 to the negative 6. 10 to the negative 6, when you look at the chart, that is going to be micro. And it's a symbol like that. So you get micro, and that is going to be, for us, answer D for number 34. Okay, we go to 35. Number 35, what is the quantity if you have 0.0075 meters and you want it in centimeters? So that equals how many centimeters? Easiest way to do it, well, there's many different ways, but here's one. You take it in meters and you put it over 1. That's your starting of giving them out. What do I know about meters to centimeters? I know 1 meter has 100 centimeters. This shows me when meters is canceled, my answer will be in centimeters, and it's a multiplication problem. Multiplying by 100 moves this 2 places closer. So it's going to be 0.75 centimeters, and that answer is going to be B for number 35. Number 36, the density is found by, someone will tell you it's the broken heart. This is number 36, it's the broken heart. Here's my heart, line through it. That's like an M over a V for the broken heart. That's density, mass over volume. So that's going to give me A for an answer for number 36. Number 37, all atoms are, well, which one holds true here? The key one is going to be C. They are neutral, and the reason is they have the same number of protons equaling electrons, and the key here is going to be, because they're equal, because they're neutral, they're called atoms and not ions. That's the difference. So the naming is important. The words you use in your answers and in the questions are important. Atoms are neutral. If it says an ion, you're looking at a charge, a plus or a minus charge. And that would be where you do not have the number of protons being equal to the number of electrons. It could be greater than or less than. Number 38. Particles that are found in the nucleus of the atom. We saw that already, so it's a repeat. I do apologize. And the nucleus is protons and neutrons. Number 39. Back side of the page. The atomic number of an element is the total number of which particles? Well, a lot of times it's written like this. We'll say, oh, nitrogen. Might look like something like that. This is the atomic number. And with the atomic number is the number of protons. Number 40. An element has an atomic number of 76. Okay, here's my element. Element X, I'll say. 76. What's the number of protons and neutrons in a neutral? That means no charge atom. And no charge means number of protons equals number of electrons. I know I have 76 because that's the atomic number. So I'm going to have 76 electrons also. That being the case, the answer is D. 76 of each. Number 41. 41 is asking, what is, when you have the 84 in krypton, 84. I have people think about carbon, for example. Carbon, the common one is carbon 14. That certainly is not the atomic number because carbon has an atomic number of 6. 14 is the mass number. That's what it represents. So on krypton, which has a mass number of 84, I'm looking for it now. Krypton looks like this. Kr 36 with an 84. that represents the mass number, which is the number of protons plus neutrons. So for number 41 then, the answer is B. Number 42. All atoms of the same element have the same what? Well, I could have different forms of carbon. I could have what's called carbon, say, 12, carbon 13, carbon 14. Well, what's different about them? Well, first off, they're carbon. They all must have 6 protons. That's what makes it carbon. So that is going to be the same number of protons. So the question is asking, they have the same what? The answer is going to be B, number of protons. And that's going to be for number 42. Number 43. Isotopes of the same element have different what? Well, let's go back and look at the number I was just working on. These are isotopes of each other. They're atoms of the same element, carbon, for example. They have the same number of protons. What's different is going to be their mass numbers. And having a different mass number means they have different numbers of neutrons. This has 6, this one has 7, and this one has 8, for example. The neutrons are different. Therefore, the answer for 43 is A. Number 44, mass number is equal to, or we just said it. It's the number of protons plus the number of neutrons. The answer is going to be B for number 44. Number 45. Using the periodic table, determine the number of neutrons in the following. Once again, this is number 45. We have 16 oxygen here. That's the mass number up here, and I know that's protons plus neutrons. And I'm asked to determine the number of neutrons. What I also know is if it's oxygen, it has to have the number 8. It must have that for protons. So therefore, how many neutrons must there be? There must be 8, because 8 plus 8 gets me that mass number of 16. So for number 45, the answer is B. 46. How many protons, electrons, and neutrons does an atom with the atomic number 50 and a mass number of 125 contain? So what we have here then is we have any atom, 50 and 125. Well, this is going to be protons. It's also going to be the electrons in this case because there's no charge on it. And then we're going to have a difference here of 75 for the neutrons. So it's 50, 50, and 75. And that's going to give me answer A. Number 47. If E is a symbol for an element, 47 is my element. Which one represents isotopes? Here are your choices. That's A. Here's the second one. Here's the third one. And here's the fourth one. And we said isotopes they must be the same element. They have to have the same atomic number. Yet they have different numbers of neutrons, and that's fine. But the atomic number has to be the same. These are the two that have them the same. So the first and the fourth, therefore for the multiple choice, the answer is C for number 47. Number 48. 48 reads, how is the number of neutrons in the nucleus of an atom calculated? I've been doing it, and I just did it right here. Number of neutrons, you take the number of protons from the mass number. And that's what I've been doing. You take the protons, subtract it from the mass number, you get your neutrons. Number 48, the answer is C. Number 49. How do isotopes of hydrogen 1? Hydrogen 1 means that's the mass number of 1, and hydrogen 2 differ. Well, it's hydrogen, so no matter what, they have to have the same atomic number. So what's different? This hydrogen 1 has no neutrons, and this one has 1 neutron. That's your difference. The answer is B. Going on to number 50. The principal quantum number indicates what property of an electron? Principal quantum number, here's my periodic table, poorly drawn, whatever, terribly drawn. I have 1, 2, 3, 4, 5, 6, 7. I have 7, and then you get the series down here. These are your principal quantum numbers, and they represent energy levels. First energy level, second energy level. third, etc. Number 51. Number 51 reads, how many energy sublevels are in the second principal energy level? So we're going to go back up to number 50. Here's my second one. Well, how many are there? There are two, the S's and the P's. So the second energy level has S's and P's, so there's two energy levels, and therefore my answer is B, or sublevels, I should say. What's the maximum number of orbitals in the F one, in the F series? F is this down here. These are my F's. There's a total of 14 electrons. That must make 7 orbitals, because we represent them as boxes sometimes, 4, 6, 7, and we fill in our electrons, 1, 2, 3, 5, 6, 7, and you come back 8, 9, 10, 11, 12, 13, 14 electrons. 7 orbitals holds 14 electrons. What that means is each orbital, there's 2 electrons per orbital. So number 52, the answer is D. Sorry about that. Next one, number 53. What's the maximum number of orbitals in P sublevel? Well, let's take a look. First of all, this is number 53. Let's go look at the P's back here. The P's are over here, poorly drawn, but I have a total of 6 electrons in the P's. Sorry. I have 6 electrons in the P's. Therefore, that's going to get me 3 orbitals. So as I go forward, it's going to be, for 53, the answer is going to be B. 54. 54, what's the maximum number of electrons in the second principal energy level? The second energy level going across contains S's and P's, and there are 2 S's, and there are 6 P's for a total of 8. So number 54, the answer is B. Number 55. If the spin of one electron is clockwise, then the other is counterclockwise. They go opposite one another, and that is C. 56. What type of atomic orbitals are third principal energy level? The third level can have S's, P's, but it also has D's. If I were to give you the bad drawing of it, that's a little better. Fine. Anyway, here's my third energy level. These here, S's. Then, this is pretty bad. I have P's. And then here, for the first time, I have D's, 3D. So I have 3S, 3P, 3D. So there's 3 different energy levels for number 56, S, P, and D only. The answer is C. Number 57. What is the next atomic orbital in the series? 1s, 2s. So 1s, 2s, 2p, 3s, 3p. What would be next? It's going to be a 4s. And that once again goes with the periodic table. Whatever. And you're just going across 1s, 2s, 2p, 3s, 3p, and then you hit the 4s before you get to your 3ds. So it's going to be a 4s for 57. The answer is D. 58. The off-bow. Off-bow principle simply states that you're going to be filling up the first, then the second, then the third. You go with the lowest energy. My analogy was in college. Here's my dorm. You don't start filling kids up at the top, because you might not need all the dorm. You start at the bottom and work your way up. So lower energy to higher energy is the way off-bow is. That's how electrons are placed in atoms. The electron configuration for potassium. Potassium, if you follow it, will go up here with it. Potassium's right here on a 4s 1s1. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. I count them up. 2, 4, 10, 12, 18, 19. Potassium has 19 electrons. I've accounted for the electrons. Number 60. How many unpaired electrons are in sulfur for number 60? Well, here's my sulfur. Sulfur has a total of, when I look at the groupings that they're in, sulfur is in group 6A or 16. There's 6 electrons, 6 valence electrons. Let's place them. 1, 2, 3, 4, 5, 6. Question is, how many unpaired? 1, 2. 2 unpaired. Electrons, the answer is going to be C. 61. What is the wavelength of an electromagnetic wave that travels at, so we have 3 times 10 to the 8th meters per second, has a frequency of 60 megahertz. Well, it looks like this first off. Here's my formula. I want to solve for wavelength. I'm going to rearrange this so I get wavelength is equal to C over nu. Wavelength is going to be equal to, well, they gave it to us, is 3 times 10 to the 8th meters per second, divided by 60 megahertz, and it's got to be in hertz. It's per second and hertz are the same. So I have to get rid of the mega. And 1 megahertz is a million, so it's 60 million. So then you would have the 60 million. And that's the one that would work. Answer is going to be C for number 61. Number 62. What is the, 62. Emission of light of an atom occurs when an electron, we had talked before about it. We said electrons jump to higher energy levels. They absorb energy. When they give off energy, they're coming back down, and energy is being given off in the form of heat and light. So as it's coming down, you're going from a higher energy state to a lower energy level. The answer for that is going to be A. 63. Which the following is in the same period as phosphorus? Periods run across. Look on your periodic table. Which one falls with phosphorus? And you're going to find out that it is going to be magnesium way down here. But magnesium is in the same period as phosphorus. So the answer for that is going to be B. 64. 64, each period of the periodic table corresponds to what? Each period, 1, 2, 3, those are energy levels. Your quantum, your principal quantum energy levels. So that's going to be answer A. 65, which is the last one I'll do on this part 2 of our review. The modern periodic table is arranged according to atomic number. 1, 2, 3. You can kind of follow it going across. It's going to be atomic number. Answer is C. Hope that's helped. Part 3, I'll do in a minute.